Hi there, it's Chris here from Technify Networks. I'm making this video in order to show you how to configure Dynamic NAT on the Cisco iOS router. In my previous video, we talked about static NAT. We said static NAT provides a one-to-one mapping of local IP addresses to public IP addresses. But with Dynamic NAT, basically, it provides one-to-many dynamic translation of private IP addresses to a pool of public IP addresses. In Dynamic NAT, we actually create a pool of public IP addresses that are available for our private IP addresses from within our network to use whenever we want to access the internet. And after a while, the router clears the translation after each translation has timed out, and it returns the IP address back to the pool of public IP addresses that we have created. So we're just going to be jumping into action quickly. I've prepared this topology to use, and I've outlined some steps that we need to follow in order to configure dynamic NAT. And with this dynamic NAT configuration, we've only got two IP addresses as well that we're going to be creating a pool for in order for our clients here to be able to access the internet. So what I've done so far is to configure IP addresses. These are our local network. These are inside local. And then this is the internet. That's the outside local. So I've configured IP addresses and the gateway. The server has got IP address, the PC, and the routers as well. So what I need to do now is to configure a default route to the pointing towards the ISP. Enable conf t. So I'm going to say IP route 0.0.0.0.0.0.0.0. Then 201. My next stop is 201.145.12.2. Yeah, and that's correct. So let's say do right. And then I'm going to configure another static route from the ISP router to our public IP address, because the ISP wants to reach us through our public IP address. The ISP does not bother to know about our private IP address because the ISP blocks private IP addresses on the internet with access list. So private IP addresses are not allowed on the internet. So I'm just going to say enable conf t for configure terminal. So then I'm going to say IP route. Then the network is 54.1.1.1.0. That's 1.0. And then the subnet mask is 255.255.255.252. So, and then the next up is 201.145.12.1. So that's that. We've created a static route to be able to reach our inside global address as well. So then I'm just going to say do show IP route to verify the static route. So we are good. Yeah. So what we need to do now is to follow the steps of configuring the dynamic NAT. So the steps we're going to be following is this: step one is to identify the inside and the local interface on our local router. And this R1 is our local router. So as we know, the inside our LAN, which with the private IP address, the inside local is always the inside IP NAT inside. And then the interface facing the ISP or the internet is always the outside network, the outside interface. So we're going to be saying interface serial 010. That will be IP NAT outside. So we can exit, and then we say interface. In this case, we have gigabit 00, and we can say IP NAT inside. So that's that. We can exit that. So we'll follow the second step. The second step will be to define a pool. Define a pool of IPv4 public addresses. That's to create a NAT pool. So this is what we're going to do. We're going to say IP NAT pool. Then we can name the pool anything. Basically, in this case, I'm going to name it Technify, uppercase. So then we're going to define our public IP addresses. We've got only two addresses. So we've got 54.1.1.1 to 54.1.1.2. And then that's the range that we've got. Then we need to enter the subnet mask with the command net mask. And then the net mask for this is 255.255.255.252 because it's a /30. So we say enter. So that is done. We've created a pool, a NAT pool. So the next step will be basically to configure a standard access list to identify and permit our private IP addresses that needs to be translated. So we're just going to identify this network and permit them to be translated into those public IP addresses whenever any of those hosts wants to access the internet. So we're going to say access list 1, then permit 192.168.10.0. That's the net ID. And then the wildcard mask is 0.0.0.255 because it's a /24. So then we say enter. So that's that. And then the next step will be to bind the ACL, the access list, to our NAT pool. So we're just going to bind it with our NAT pool to our NAT pool. And the name of our NAT pool is Technify. So we're going to say IP NAT inside source list. The name of the number of the access list is access list 1. So then that's source list 1. Then the pool, we're gonna now name the pool which we named Technify. We're gonna bind it to this access list as well. So we're gonna say Technify. That's case sensitive. So enter. And that should be about that. So let me just say do write. So now I can say do show IP NAT statistics. So we can see here the start address and the end address is 111.11.2, and then the total addresses we have is 2. So that's what we did over there just now. So then we can say with this, let me use Ctrl+Z, we can say show IP NAT translations. There will be nothing yet because we've not done anything yet. So what we're going to be doing here is this. We're going to access this server. We're going to make an HTTP request to that server. So from this PC, we'll say, okay, let's do HTTPS // let's say 60.1.1, I mean 60.10.10.5. So that was successful. We are able to open that. Then on the next PC, we're gonna do something similar, but this time around we'll just use HTTP on port 80. So we're gonna say 60.10.10.5. So because we have two public IP addresses in our pool, the third PC will not be able to make an HTTP request, because HTTP translations, it takes 24 hours for the router for it to time out before the router will clear it off from the translation. So if we try now, we won't be able to do it from here. 60.10.10.5. So that won't work. Even if we try to ping, we won't be able to ping. That's the limitation of Dynamic NAT. So the ping will not work because the translation is going to stay active. The HTTP translation is going to stay active for 24 hours, although that can be configured to a lesser time, to a lesser duration of time. And as we can see, this is the request we made from our inside local 10.5 on port 443. That's the HTTPS request that we made. And then we made another HTTP request on port 80 from 192.168.10.6 to this same server. So that's on port 80. So, and that's our public IP addresses. We've used one, the 54.1.1.1 on port 1025, and we've used 54.1.1.2 on port 1025 as well. So every other PC here, they are not able to access the internet until I clear the NAT translation. So I'm gonna do this quickly. I'm gonna be pinging continuously and then clear the translation. Then we can see what we are talking about. So I'm gonna do a continuous ping from here. Ping -t. So it's not gonna work until I clear the translation here. So I'm just gonna do clear IP NAT translation, then with asterisk. So that is done, and then we can see now that this ping is now successful. So if I stop that, the only translation I'm gonna see there now will be ICMP. So, and that's from that PC. That's all ICMP. Yeah. So, and that's from .7 192.168.10.7 from this PC, which was going to that server, and that's all ICMP echo reply and request. So that's about that for Dynamic NAT. So if you find this video helpful, give it thumbs up and don't forget to subscribe to our YouTube channel. See you in the next video. Okay, thank you. Bye.